All right, I'll probably end up going through this somewhat quick. So ask lots of questions because I am not planning on dwelling on a lot of stuff. The RGB, does it make it super fast? It makes it not super fast, it makes it just 3 times as fast. Exactly 3 times. It's a 3x improvement. So you'll notice that this laptop runs really quick. It's actually a 6x because it has a keyboard that's RGB. And then the servers, you can tell that those run very fast too because they have RGB on that switch. So very important, get RGB on your stuff. If it doesn't have it, it's not modern. Yes, it is proportional to the speed of cycle. Yep, there, I just sped it up. Yeah. All right, so what I'm talking about is all of the stuff that Colin just mentioned. I'm glad he mentioned it because I was going to rabbit trail on those inevitably. So he kind of touched on most of the ones that I was going to rabbit trail on, which is very nice. I am still going to touch on them lightly, but I'm going to talk about a little bit about what the mission was when I started this task. And with that, I'm going to share this screen. So this was kind of my utopia. This is what I was attempting to get to. You can see that I got there, so yay me. It took a very long time, and no work was done on this lab outside of the hours of 10 p.m. and 4 a.m. It was all in the middle of the night because I had to work up and do regular work like everybody else does here. So, yep, very boring stuff. So this was very educational, is what I'm going to start with. So it's very, very educational. And with that, I'm going to switch back to where I started. So the first place I started was I spun up XCP-ng because I've been using that for a while. That's a forked version of Citrix Zen server. It used to be a really nice server with like unlimited pooling of servers and pretty nice server. I see some sideways bobbing. Pretty nice server architecture. I always liked it better than ESXi because licensing problems. Until about 2014, I think it was, they released a super awesome version of Zen server, and it had like everything that anybody would want. And then a couple months later, they released the next version that locked all those things behind a paywall. So they're like, hey, we got everything you want. Now that you know what it is, come give us money. So somebody went out and forked that project and created XCP-ng, which is, it was a very, very nice product for a very long time. It kept on getting better and better and better until the most recent version, which had a very significant limitation to what I was trying to do, and that is XCP-ng 8.3 does not support nested virtualization. So if you're trying to run a virtual hypervisor inside of your hypervised machine, not bare metal, you're kind of a little bit out of luck. So I started down that path, and this is the first thing that you get once you run the install package and you step through all the, yeah, I do want to install this stuff. You get the XO Lite, which is very, very minimal. It comes prepackaged. You just hit the IP of the server, and this pops up. So I immediately went to spin up the XOA, which is the included a little bit nicer version of this, and that looks like a little bit like this, but I'm going to get to that in a second. So I spun that up. I didn't like that a lot of the things were locked behind some of the paywall. Most of it is all usable, but I was an avid build it from source, they said. So I went and built it from source and spun up, ran really great. You basically have an interface that looks like this one. You have an interface that looks like this. It's a little bit dated. They are updating the interfaces. It has some of the nice things on it that you'd want to track. It has really nice backup features. So if you're trying to back up your virtual range, you can connect it into pretty much anything. So you just point it at a destination and run your scheduled backups, and it'll back up your entire range, keep your snapshots and everything safe. So if you do have a catastrophic failure by plugging into a power cord hanging from the ceiling into your power rack, it doesn't matter. You can recover from backup. I don't have an ups on this range. So that was really nice. I love the backup features of XCP-ng, but after running through trying to get the GNS3 server started and hosting my virtual machines, which are a combination of KVM hypervised virtual machines, so QCOW2 format, which is mostly your ESXi is using that on the back end. It would not spin up any of my machines. So I troubleshot forever. It was a good 30 hours of troubleshooting why none of my servers would spin up. I'd get to this screen and I'd try to drop stuff onto the network map and turn them on, and it would just error out. So after Redditing for a very, very long period of time, I figured out that on that specific release that I had just pulled straight from their site, nested virtualization was broken. They did not intend to have it broken. They're working on it, but right now it is. So with that, I switched over to Proxmox, which I'm realizing I didn't have Proxmox up. I'm not going to waste your time to try to bring that up. I switched over to Proxmox, and that one just worked. So it's also based on KVM, which is kernel virtualization module, the Linux default hypervisor that you can get on any Linux machine. And during that period of time, I spun up what I intended to be a Docker host and a XO host, accidentally installed all the features of the server, which got me to Nextcloud. And I was like, oh, this is cool. I can host all my emails and stuff. So that was the first rabbit trail that Colin kind of took off my plate. So I don't need to go down that trail. That was a very nice experience. It's super easy. You just grab the Ubuntu full server install and you say, install Nextcloud. It runs through the install script, everything runs up and it says, go to this IP. And you go to that IP, it brings up and it says, go ahead and add your users and here's your emails and all that kind of stuff. That was super nice. The next thing I did was I moved into the network side of the house. I had done some Linux-based firewalls and routers and stuff like that using my home, formerly Mediacom router. And it was like, okay, but just not ideal. So after a while, I finally switched over to Unify, and I am a Unify fanboy. I know it has some security issues, but once again, risk-informed. The features are so stinking nice that it's very hard to go back. So what you're seeing right here, and I'm going to do the show internet traffic just because I can. What you're seeing here is me running on this machine. That machine in the middle, the icon's not currently correct, but it'll discover that and fix it later. It'll show my computer the ROG Zephyrus icon. It'll actually get that icon and load it on there. But you can see which machine is using all that data currently, which is super nice. And when you install this on a home network, all of your stuff, including all of your Wi-Fi connected stuff, you'll start to see which of your IoT devices are sending traffic. And then you can also start to see what your network is doing. I'm going to switch over to the insights because this is super cool now. Maybe. No flows right now. I haven't had it running long enough. That's unfortunate. Maybe Geo. Yeah, here we go. So as I started using the network, I was like, well, I want my lab to be relatively secure. So I went and started configuring the firewall. So I'm going to switch over to the security tab here and the firewall. And of course, I have not updated this. I'm going to update it live. We're going to let that run in the background. It's updated. So we just switched over to a new firewall. This is one of the best innovations that Unify has implemented recently. So this is a matrix-based firewall. So I can go into my policies here and say I want to take anything from the VPN or I'm going to do DMZ. So say I'm running all my servers in the DMZ. I want to say that they are allowed to reach the external, like the internet. So I'm going to go here and I'm going to go here. I'm saying they're allowed to reach the internet. It lists all of the firewall rules that are specifically scoped to that area. So now, as I'm starting to build out my lab, I can very rapidly start to isolate my lab, so I'm not having all the malicious things that I'm intentionally building on this lab, like damn vulnerable Linux, if you've ever played with that, like all of the things that you absolutely would not want to host on your local network because they are a pivot target, you start isolating those into your separate areas. So DMZ to, if you look at here, DMZ to internal, that is not allowed. But if I go from my internal network, which is like my home computers and stuff like that, out to my DMZ, I can go outbound, and then it'll allow that established traffic back in. This is like just a super, super nice visual way of seeing your firewall. And then it has your little guide of what your network might look like here. So once I got that configured, I'm going to switch back over to the insights here and go back over to Geo. I got my network kind of configured, and I started isolating all of my IoT stuff from my lab. So this server here is isolated from everything else on my home network, and it's also isolated from my IoT devices. And something I started noticing from my IoT range, because you can filter down on that, is that all of it was talking to China, like persistently. And the way I found out which devices were talking to China is I just went over to I did this right here. I went and hovered over the country and said, I don't like that they're talking to that, and then I blocked it. That's how you block a country. And so now I have the region-based blocking enabled on my network. I started to see, oh, yeah, these are the devices I do not ever want to have, even talking to my other IoT devices. Because if you have Google devices or Amazon devices, and you're watching that traffic, you'll notice that it's sending tremendous amounts of data back to Amazon and Google, because they're making those things really cheap so that they can listen to what you're saying and then start making ad recommendations to you. Like Amazon is the worst because they're very good at it. Google is a little bit better. Still, they do some of it, but it's not so obvious. Amazon in their Alexa app says, yeah, we're collecting all this, unless you specifically disable it, and you got to go through like 10 steps to disable that listening. So I started just doing it from the network. I started blocking the stuff I didn't want to see on my network directly from here, and it's super easy. So you can get into the UniFi space with the UniFi Express router for about $100 when they're on sale, 140 I think at the higher end of the UniFi Express routers, which has most all of this same stuff. It's going to have your network map, it's going to have some of your traffic flows, it's going to have your firewall and stuff like that. It might not have the really nice matrix-based firewall, but it's still going to have your basic firewall stuff that you can do and the country blocking. So once I got that configured, switch back over to topology. The next thing was starting to build out my range. So I talked about the fact that I already have GNS3 hosted, and I have these out of order here. And I'll drop all these links. I didn't build a huge presentation because these YouTube videos exist already. So I'm just going to click through a couple of the images on the YouTube videos to talk about it. So after I set up Proxmox, I went in and I can get back to my picture here. So got Proxmox set up, and this video is probably my favorite one on installing XCP or GNS3 on Proxmox. So you spin up your Proxmox. This is basically what you have. You can spin up a whole bunch of servers. Like you can use laptops to virtualize this. I mostly brought this rack just because it's pretty. It's not actually needed for anything that you need to do in this lab. So I can run it on this laptop. I can run it on this much older laptop, and I can also run it on his laptop. Has totally enough power to do everything that I'm going to show you here. So I did it because it's pretty. So it's very pretty. I really like it. So anyway, sidetrack. Got Proxmox stood up, and once you get Proxmox stood up, you install a Linux server. So you just use your Ubuntu basic Linux server. You spin that up. If you want to have the user interface, which is kind of nice, you install it with the GUI. Once you get that installed, I'm going to skip through. There's the install process. I'm not going to bore you with installing GNS3 from a terminal because it never works live. So it goes through, installs, and once you get that installed and you have, there's one specific thing that you want to make sure is configured, which is to configure the GNS3 VM to have direct access to your host device. so that it's not doing only its virtualized system. That's going to make it run really fast. It's going to make it very performant. And I'm looking for the picture. I think it's right. It's right around here somewhere. I nearly have this memorized now. So anyway, watch the video. You're not going to remember if I tell you where it is anyway. So watch the video. I'll drop it in Discord at the end of this. So once you get that set up and you configure, I think there's only 2 configurations that you do inside of the hypervisor to get GNS3 to boot correctly. I have all my GNS3 shamedly configured for DHCP, which is really nice because if I need to go and configure what that IP is, I can literally just click on it and lock the IP to that server. So I don't need to do a whole bunch of fancy static assignment and then try to remember where the server was. Now I'm trying to remember where the server, there we go, where the server was. So I can go in here and assign that, that IP address as a fixed IP address. So if I click that, now it's assigned. And I can also add a local DNS record. So I don't need to go and statically assign anything. I can just set everything on my network to be DHCP. It's going to auto-discover everything. It's going to auto-add the network routes and everything else. So it's just super, super, super easy. Once you get that done, I'm going to skip over that tab. You'll be able to get to the GNS3 VM. Once that's done, you're going to go in and configure that VM to be accessible by the GNS3 client. So I'm going to go through here, and I'm going to skip through this very, very quickly. So if you have questions, please ask them. So inside here, you got a couple different options for what you can configure for GNS3 virtualizers. So you can put the GNS3 server, a remote server that you've either directly bare metal installed a Ubuntu bare metal OS and then installed the GNS3 package, or you can put it on Proxmox, which is what I did, so I can revert an entire range and not worry about crashing it when I throw it out to the public, like B-Sides, what I did. So I can put it out there and let anybody play with that range, give them the admin creds, and they'll be able to do whatever they want and crash it, and it doesn't matter, because I can just go back to the end of the exercise, revert the virtual machine, and now everything's back to where it was. So I'm going to speed up here a little bit. It can do a whole bunch of stuff like network analysis and stuff like that. There are virtual hubs and Ethernet switches, which I'll talk about here in a second. It can also do dynamic MIPS. I don't know how to say that. To be able to virtualize all your iOS routers, all your Cisco devices, you can virtualize all of those Cisco devices by going out and grabbing the bin off of a Cisco device and copying that into this thing, and you can virtualize all your network switches, which you'll see in a second. It's also got, it's got this version of the Cisco device hypervisor. They changed over their base kernel, which is what this one is. It's also got the older iOS and Unix version of iOS devices for Linux, which they've largely moved away from. And then you can do your QEMU. So if you have a Linux server, you're not running XCPNG, you're not running Proxmox, you're not running ESXi, you just have literally a Ubuntu server, you can configure that to turn on the KVM module and then point this at that server, and you can start building virtual machines on that server without touching it, which is super nice, and you'll see that in a second. You can also connect it into VirtualBox. So if you're running on a laptop and you don't have the infrastructure to spin up a dedicated CLI-only interface, just spin up VirtualBox or VMware Workstation, because that is now free. So you spin up any one of those things, and once you get all of the different servers that you want to deploy systems to, you can literally add those over here on the right-hand side, the server summary, and deploy machines to all of those machines. And so you can kind of load balance your entire range. So you can build gigantic ranges just by leveraging the computers in your house. You don't need to buy servers. You don't need to have a super high performance laptop. Just throw one machine on one little tiny laptop with a 1.5 meg or gig processor. It'll work great. So there's the VMware. Yeah, yep. So there's VMware, and then it also supports Docker. Docker containers. So if you want a Docker container host, you can spin up a Docker server somewhere and then point this over to that Docker server, and you can start dragging Docker containers onto your network map as well, and those will dynamically spin up. So with all of the configs, I'm not diving into any of these deeply because they're so heavily covered on YouTube. It's beautiful. I'm going to switch over to now how do I start getting these virtual machines available to deploy. So these do not come default. There's like 2 switches that come default. I'll jump over here, all devices. So there's this switch here comes default. None of the Cisco switches come default. There's the Ethernet hub, this Ethernet switch, the frame relay switch, virtual PC, which is kind of nice. I'm going to drag one of those over here. You got your virtual PC, and then none of those other servers come default. But they are very, very, very easy to add. So I'm going to go over here and try to remember how I did it. So you're going to go import appliance. Oh, hold on. I'm going to do a different one. Import. I think it is the portable project might be, no. I'll find it here in a second. It's got to be the new template. Yeah, here we go. So you go to the import new template, and you say where you're going to install that template at. So what these templates are is think of like building a virtual machine, having it stored, turned off, and you want to copy that virtual machine over to create a new virtual machine and link the base image. This is essentially what you're doing here. So you're creating any kind of hypervised image or switch or whatever so that you can use it later. So here's the first one. I'm going to install it on the server. So you see the main server here. That's actually running on one of these servers in the rack. And you can see it's not using anything, just reinforcing the fact that you can run this on your laptop. So it's not using hardly any resources. With the stuff I'm running, we'll get it up to like 3% here in a second. And I want to go down to guess, and I want to do Alpine Linux here, because I already have the things downloaded for that. Install on the main server, which is this main server here that I'm running on. And this one might already be done, so I might not be able to redo that one. Ooh, very noisy. Calm down there. Let's do a different one, because I do have that one added. Import. No, wrong one. I'll remember eventually. New template. And that one. Guess. Let's do one that I don't have. It is a Linux machine. So it's going to go and ask you what your virtualization module is. So this is the QEMU binary that I'm going to use to virtualize this machine. I'm just leaving it the default one that it selects. And then it's going to say, what do I need to build this virtual machine? The beautiful thing that came out in GNS 3 version, I think it's 2, GNS 3 version 2, is that they started adding these template guides. And so I can go out here and I can do, it says I don't have the files I need to build this template yet, but it tells you where to get them. So it says, here's your ISO. I'm going to go ahead and click download. It's going to take me out to, this isn't a great example. This is probably a very not well-known Linux machine. That's why I was trying to use the Alpine. But it goes and grabs that ISO. It downloads it from open source. Even if the Windows ones are out there, you can go onto the Windows site. It'll direct you over there, and it's going to grab the dev Windows environment that's good for 90 days, and then it reverts. And so you can use those in ranged environments really well. And then you're going to grab your virtual hard drive image. So this is using a 30 gig empty, and I'm going to import this guy. And let's see if I can remember where it is. I don't have that plugged in, so we're going to skip that. So you import your downloaded file, which is super small, 192 kilobits. And then once you do that, you can go over and create your virtual machine. So I've done that for these machines over here on the right-hand or left-hand side. Now, once it's there, that's really pretty and beautiful because I can literally do this. And now I've just created a new virtual machine. I didn't go through a whole bunch of new machine builds and everything else. I literally just dragged it over there. If I want to connect it to a switch, I click that guy and it says what network adapters I have configured on it, which is really sweet. So I can add a whole bunch of network adapters if I want to. I'm going to click that one, and then I'm going to go plug it into a switch. This one has a couple ports open still. And now I've connected that virtual machine that I just created in a couple seconds into a virtual switch that can also access the public internet. Because if you notice here, well, not this one. This one up here can. This one is an isolated network. So let's exit. Move this guy over so you can see that network a little bit better. So this network here is my air-gapped network. It cannot access the internet. This network up here is connected into this cloud object, which is basically what that's doing is bridging all of your virtual network interfaces over to this server's internet connection. So it allows you to take all of your virtualized range and plug it into a real range, which is really nice because if I take these machines now, go ahead and select this guy, we're going to go ahead and start him. So you'll notice that these machines are starting to spin up. You'll see some CPU and RAM start to be consumed here, and you'll see that these icons are going green, saying that these devices are now turned on and connected to the network. I'm going to rapidly switch back over to this view here. Hold on here. This one here. And what you'll notice is this is my actual switch. This is the actual switch that's plugged into the internet. If you notice, I have a long wire that goes out that way to space. It's connected out to space, and all of these machines will start to show up on this live network map as those machines come live. So if I zoom in here, I'm not going to wait for all of them to come live, but you can see I have my GNS3 VM. This is the one that was hosted on XCP-NG, and this one will not work. But there went another one. There's another one just spun up and got added to the network, and it's live discovering all of these hosts, and so I know everything that's on my network. Like, if it gets on my network and can talk to anything, I can see it. So that's really, really, really nice because you don't have unidentified devices anymore. You identify them live. And this one also starts to identify what is running on there. So it identified that's a Linux. There's my Windows machine that just got added as it's spinning up and it's booting up. And it's dynamically figuring out where all of this stuff is plugged in. So with that bridged interface for these virtual machines, you notice that they're not plugged into, like this example here. Here's my hypervisor. This is the XCP-NG hypervisor that I'm not using. I just have it turned on for example because it doesn't work for nested virtualization. So there's my hypervisor. It'll jump back over to this switch to show that hypervisor physical server is actually plugged into this switch. There it went. So it's plugged into this physical switch. And then it also shows that it has 2 virtual machines running on it. So now I can start mapping my virtual machines to my servers that are actually hosting them, which is really nice. I can figure out where those things live. If you're trying to map a network rapidly, this is an absolutely invaluable tool. Get a little UPS, roll around your network campus, take one of the UniFi Expresses, plug in the 2 ports, plug in a little 4-port switch, plug it into that network switch, and it'll start discovering everything that's plugged in. It'll discover all of the machines on that network, and it'll discover what ports they're plugged into, how far away they are, and everything. So you can identify everything on your network really quick, which I've used quite a bit. And then you can start building out your virtualized networks really, really quick. So let's jump back over. I don't want to bore you too much on that one. So once you get your GNS3, I'm going to switch back over to this one here now. Once you get your GNS3 configured and up and running and you got your templates added, which is a pretty quick process. I mean, it's just your internet speed, how long it takes to download. If you search for Cisco images, you might be able to find them on GitHub. That is not an approved place, but sometimes people load them on the bin packages on GitHub. Because Cisco, you have to go inside of their, like you got to create an account, usually have to be a commercial vendor, and they'll be like, yeah, you can download all the bin images. Or you have to own one of their devices and then SSH that bin file down from the actual switch, which you can do, which I got a lot of these from Cisco images or Cisco switches that I've owned before. They're sitting in a shed somewhere not doing anything because I can do it all here. I don't need to have that real infrastructure, and it runs way cheaper because you're not running all that power. So now if I want to get into this machine, I can go ahead and see that started. I'm going to go to console. And what this is essentially doing is it's just spinning up a remote desktop to that machine. So there is my actual machine. And I can go and configure this machine to have whatever I want on it, and I can save that template off. So if I want to configure this machine to intentionally be vulnerable to an attack to run like a CDC, a cyber defense competition, I can configure that machine, save it off as the template, and whenever I want to spin that up on a new network, I just drag it onto that network and plug it in. And that's building machines as fast as I can. And if you are none the wiser, like if you're a server, a network administrator, and you're trying to defend your network, and all of a sudden you see all these devices popping up, it's very hard to identify where they're coming from, what they're used for, and if you're able to spin up a machine that fast, run all your stuff, and delete it, that's scrubbing all of your information about that machine just disappears off the network. So from a forensics perspective, it makes it very, very hard in a CDC to figure out who that machine was, what they did, all that kind of stuff, because it just came up and it disappeared. So it's a pretty neat tactic to use. So with that, I'm running, let's see, seven minutes. I think I go till 9. I don't know what my time is, 7 minutes. So with that, any questions that you have before I kind of wrap it up? Like, where should I get started, or how much did it cost, or why did you do that? That was really dumb. You'll have to yell pretty loud. It's very noisy up here. You don't. So let's switch back over there. That's very question. I'll repeat it here. So the question was, for Ubiquity, do you have to have all Ubiquity stuff, or is it just some Ubiquity stuff? It's best if you have all Ubiquity stuff, but it is absolutely not required. What you're going to see when you have just some Ubiquity stuff, the most important thing from Ubiquity that you want to get is the router. So you want to get a Unify Express, which is a super cheap, small thing, which I'll talk about the things you can do with that in a second. Super cheap, small thing you can throw on your range and do all those configurations. Just plug that Ubiquity into your current internet, and it'll be the front to your entire internal range. And then when you start plugging other things in, so you see I have another Unify switch. The really, really nice thing about this Unify switch, I'm going to switch over to devices here. The really nice thing about this Unify switch is you can do all kinds of really nice management and auto VLAN assignment, and you can go in and change the colors of the ports on this particular switch because RGB makes it go faster. Super nice. You can also isolate. You did 3 times faster. Yes, yep, it does. RGB makes it go 3 times faster. So you can also make it auto assign. You can configure active routes. You can do all of the really nice third layer routing. So this is a layer 3 switch that I'm running here. They also have layer 2 switches that don't have your configurations. They're just one VLAN. This one you can isolate this guy and do pretty much everything you can do with a router. But since I have it plugged into a router, it makes it really easy to manage. If you don't have a Unify switch plugged into your router, it'll show up, but you will have to go and manually configure all those VLANs on that switch. So you have to CLI into it and configure it. It's not going to troubleshoot and tell you what's going on with it, or if you have an issue, if you misconfigure that switch. It's just going to show everything plugged into that switch as if it was plugged directly into your router. So it doesn't do that in between discovery usually. So that's a very good question. GNS3 is free. It is 100% free. And they have labs. They have labs for days. So if you want to get your CCNA, or if you want to do any kind of enterprise understanding of what a network looks like, you can go to their labs here and download those labs and actually run through, okay, I need this switch. I need to figure out how to configure BGP. It'll actually walk you through how to configure all that stuff with their labs. Oh, yes. So I don't know if you can see the server. You can't see the server. He'll point the camera down at the setup here, which is very fancy. So the purpose of this server and all of the patch cables that are actually plugged into this, which look super unnecessary, is it serves 2 purposes. The first purpose is to be completely unnecessary and pretty. That's probably the first and most important purpose of all those patch cables. The second purpose is to run a distributed operation. So this is my domestic operations lab, is what this is called. So you see domestic operations. What we do on the Guard side, so the National Guard, Iowa National Guard, which is Army and Air, we do support for the state. That's our number one mission. Every 2.5 to 4.5 years, depending on what type of career field you're in, you might actually get activated to Title 10. You're on a constant rotation of going to Title 10 and being active duty Air Force or Army. But when we're not activated, when we're on state duty, we go and help the state do critical infrastructure defense. So right now, it's a great segue to what this screen is displaying. Right now, what we're focusing on is CISA and Homeland Security is focusing on critical infrastructure, because a couple things have been happening in the last couple of years. Hostile actors have been very heavily targeting our water infrastructure. So out in Pennsylvania, you can look this up on Google, out in Pennsylvania, somebody hacked a water tower, turned off a critical pressure relief valve, and overpressurized the water tower and blew it up. That's bad. You don't want that to happen. So that became the first major kinetic effect through cyberspace. We want to defend against that. Shortly after that, down in Florida, somebody hacked a water treatment facility and cranked all the caustic chemicals up, like the poisonous chemicals that usually just kill bacteria, but if you crank it up high enough, it'll kill people. And that starts to flood that chemical out into the pipelines. I'm sure all of you have heard of Flint, Michigan. You might not know what Flint, Michigan was about, but what happened in Flint, Michigan was they had a change in the water chemical content. They're not exactly sure why. They have some hypothesis why those chemicals went so high. And what it did is it went through the iron pipes that were in that city, and it stripped the oxidation layer off of those pipes. And so now, it might not have had a high enough chemical concentration to kill the people at the end point, but it did have enough concentration to strip those pipes, and now everybody's getting lead poisoning. So it was a tertiary attack or effect. There's no attribution for that. There's nothing saying that it was a hostile actor that did it. It could have been something as simple as when they switched from the commercial water that they used to be going to their local water source. I don't remember if it was wells or river. Just the chemical content in that water didn't get treated successfully. And so it stripped those pipes and started poisoning people, and they had to replace all their pipes. Currently here in Iowa, in Des Moines, we're doing the same thing with the lead pipes. We're stripping them all out just to prevent that tentative emergency from happening. So once again, National Guard does critical infrastructure defense. They help out with CISA, and they help out with Homeland Security, which is a state entity. They're funded nationally, but they're a state entity, and they're mostly focused on things like election security and water treatment facility and power plants and stuff like that. So we'll go and do evaluations on those entities to make sure that they're as secure as they can be. And this allows us to virtualize that environment, which is the next picture that I'll show here. Actually, I'm going to jump back over to an example one here. This was a tabletop we played. And we basically created a whole bunch of virtual machines to say, this is our hypothesis of what this range looks like. We went and ran an attack on that virtual range, and we found that on that current configuration, it was very vulnerable to all kinds of attacks. So we made recommendations back to the partners that we were assisting with that tabletop, and they went and changed a bunch of stuff, which allows us to have secure elections. I'm not going to get into a whole bunch of details about that, because that's way above my pay grade. I'll let a general talk to you about that, or Secretary of State talk to you about that. But we can virtualize all that stuff out, which is the purpose of this screen. So on this screen, what I have running right now is I'll zoom into that area. I have the water treatment facility virtualization. I'm just using City Skylines to virtualize that. But the neat thing about any of your network games is they're sending network traffic, which is pseudo-representing that network traffic that exists on a real network. When you're starting to do initial understanding of how infrastructure works, you're going to want to jump into something like that to understand, okay, this is in general how these things need to communicate. And I thought I had my water treatment one on here. I do not. The actual video. I'll try to post that in in Discord as well. It's antigraphs how a water treatment facility works, and it steps through all the components, which allows you to understand where those critical vulnerabilities can be and show up. Once you understand that, you can start looking at real network traffic and understand that, oh, shoot, yeah, I need to protect this part of the VLAN. I need to jump into my network defense system and jump over to my security tab and start watching what is going on with my security on my network. Oh, that's not where I wanted to go. I wanted to go to Insights. So I can start watching things like, what is this infrastructure trying to talk to? Like if you're talking critical infrastructure that's hypothetically supposed to be air-gapped, you plug in and you're starting to monitor with something like this, and you say, why do I see stuff from China? Why do I see stuff from Russia? Why do I see that kind of traffic? And that'll start to allow you to dig a little bit deeper into what is going on with your networks. It's a very good question. Any other questions or comments? I just want to say a call out to Central Campus, Des Moines Tech Education. We are building out some of this range capabilities at that location, downtown Des Moines, and we're planning on hosting basically the ability to spin up CDCs from partnering with Central Campus and their program. So if you have a very small high school or something like that, and you're like, I want to teach my students cybersecurity, but I don't have any time or anything else, or infrastructure, most importantly, to actually spin up a range and show them how these attacks happen, how do you defend a network, how do I see as the VPN provider, because that's another conversation, how do I see what your traffic is? So with Downtown's or IT Tech Education's environment, they're actually running one of the nicer Unify devices. Mike, can I switch over to that one? Awesome. I got a thumbs up. So they have one of the a little bit nicer devices that they're running, and let's see. And I don't have a really good picture of it. Theirs actually can do deep packet inspection, where you basically put the certificates on all of your host endpoints. So all of these machines here would have the certificates loaded on them, so it can do that decryption of traffic, whether it's searching for stuff on the internet or whatever, and that's going to show up on, say, a dashboard. So it starts to educate students that whatever you do on your computer can be seen by the person that owns the network. Like, there is no protection of what you're doing on your computer if you do not 100% own the network, because I can see it. I can see what you're searching for. I can see what you're getting. I can see, if you're searching for things that absolutely should not show up at a school, or more importantly, if that school is being targeted by hostile actors, which we saw in Des Moines Public Schools. We've been seeing a lot of those attacks recently. If they're being targeted by those hostile actors to get you to click on an email, you'll be able to see that email click and go out to a malicious actor, and it'll flag that malicious content and say, hey, a C2 command and control was just set up on your domain. So this router is way nicer. I think they run $1,600, $1,900 for the one that runs down there. Those are like 12 gigabits per second, deep packet inspection, decryption of traffic, everything you would possibly want. You had a question too. Go ahead. Does it what? So the question was, if you're running basically a malicious server on your range or on your domain, and you're trying to do all kinds of malicious stuff. Oh, VPN service. It can see it before it hits the VPN. So what I have here is, I'm going to go back to this one here, because this is super pretty. So what I've got here, and I don't have this one connected. Let me see if I can do a quick connection. Okay. So what I have here is SiteMagic, and I can actually set up a two-way VPN between my servers at my house and Central Campus's. So just like you do VPN into your work, I can set that up with a couple clicks. And this isn't the best one to show, but it's configured so that you literally go in here and select, I want this one to connect with, if there was another one down here, which I'm not showing currently, I want to connect it to another VPN on the other side. It'll encrypt that traffic between the two devices. But to your point, As soon as you get inside that network, that decryption is gone. The VPN is gone. So if you're doing a VPN from a host machine and you have the certificates installed, it can still decrypt that traffic before it goes into the encrypted tunnel. It can. You have to do some configuration. This one will do point-to-point from site to site, and yours that you're talking about generally is from a client to client, so it's from your laptop. So I think I've got a client running here. Yeah, so like this one here. So I can do, let's see. So I can do something like this, Open VPN. I can go in and try to connect. This isn't going to connect anything. It's not configured. But I can try to connect from this laptop right here back to somewhere else. And if you are encrypting your traffic from your device to that destination, you don't have the certificates installed, which from a nice device like this, you just require them to be installed when you connect to the device using Radius and a couple other ways that you can do, OpenNAC and some other things, to force people to get those certificates installed if they're going to use your network. So you can basically open up a network to public Wi-Fi or whatever, have those certificates installed, have that disclaimer saying all of your traffic is going to be monitored, do not do malicious things on my network, and you're fairly confident that there is not malicious stuff going on because you can see that traffic. You're going to ask a question too. No, you got it. Okay. Any other ones? Awesome. Well, thanks for coming to my talk. If you want to come up and look at anything or poke at the screen or whatever, feel free to.